Chapter 7, chemical reactions. Chapter 6 had a lot of math in it. Chapter 7, not so much math. So that's good news for some people, bad news for others. So this first section is kind of touchy-feely. Just sort of examples of chemical reactions. The space shuttle, you know, big clouds of smoke and it lifts off into the air. It's really cool. Part of why it can lift off into the air is a chemical reaction between hydrogen and oxygen to form water, of all things. Okay? Chemical reaction that emits a great deal of energy and propels the space shuttle. So what is a chemical reaction? A chemical reaction is the transformation of one or more substances into different substances. A chemical reaction is a chemical change. Your book talks about kindergarten volcanoes. I don't think they actually do these in kindergarten. They're really more like a 4th grade volcano, right? Yeah. But you mix baking soda and vinegar and it foams. And if you put a little red food coloring in there, you can kind of make it look like lava, right? And so you spend all this time making this paper mache mountain, and then you pour the stuff in there and it goes, whoa, and bubbles up and over the sides. And then you've made a really big mess, too. And hopefully now that we have cell phones and stuff, you at least took a video of it so you can enjoy it over and over again. But what's going on when you mix the baking soda and the vinegar? It's a chemical reaction. It bubbles up like that because it's releasing carbon dioxide gas. That sort of a reaction is part of a group called gas evolution reactions. They are reactions that evolve a gas. So a gas is formed in the reaction. Another type of reaction is the combustion reaction. This happens in your car. Most of you probably got to school today, if not in a car, in a bus or something that used an internal combustion engine. Okay, so the compounds in the gasoline. Here's a model of octane. That's one component of gasoline. There are many other similar compounds in gasoline. This reacts with oxygen. It burns, undergoing a chemical reaction and producing carbon dioxide and water, and a great deal of energy that causes your engine to move and causes you to move because you're in the car. It's a combustion reaction. Another type of reaction is a precipitation reaction, and this happens in your washing machine and also around the sink area in your bathroom. There's a reason that we use laundry detergent instead of like hand soap to wash our clothes. Hand soap forms a precipitate with the hard water, the calcium and the magnesium in the water, and forms this gray, slimy stuff. It's called curd or soap scum. So here we have an illustration of soap in pure water, and it bubbles up nicely and the water still looks fairly clear. When we put the same amount of soap in hard water, it doesn't foam up very well. My parents have a water softener, and man, you wash your hands and you just get bubbles and bubbles. I mean, it's like crazy, because I'm used to having the hard water that we have in Reedley, and you probably have hard water here in Visalia too. And it just doesn't, you need more soap to get any sudsing.
What's hard water?
Hard water is water that has minerals in it.
Okay.
Yeah, it's not actually harder than regular water.
Ice.
Yeah, ice would be hard water. Yeah, yeah, different use of the word hard. So what's happening there? The reason the laundry detergents work better is because they've added sodium carbonate and other compounds, and what those do is they I can't tell what I'm pointing at. There we go. Sodium carbonate, which is similar to baking soda, but it's not exactly the same. You can buy it, it's called washing soda. The carbonate ions will react with the calcium and the magnesium and cause them to precipitate out, basically getting them out of the way so that they don't interact with the soap. It neutralizes them. Usually we use the word neutralize for acids and bases, but yes, it gets them out of the picture. So if you're talking about, neutralizing your enemy, that sort of neutralize, yeah, it gets them out of the way. And so those are going to settle out to the bottom, and they're just going to end up being washed away. But, you know, in your bathroom, the soap scum that you see that gets around the faucets and stuff, that's caused by the calcium and magnesium ions in your water.
So is it best to use laundry soap to wash them?
It's best to use specifically designed laundry washing products for your laundry. Because if you try to use soap, your clothes are going to get a lot grayer, especially your whites are going to get gray. Some of my friends are really into making their own laundry detergent, and, you know, because you can save lots of money. Well, I tried that. The problem is, you know, those companies have spent a lot of money on laundry detergent, and they know what they're doing. So there's issues with hard water. There's also issues with, yeah, you got the dirt off the clothes, you know, but maybe there was some really dirty socks in there, and now you've just spread the dirt around to all the other clothes, redeposition of soil, and so dirt just, you know, it came off, but then it goes back on, and you end up things getting grungy and smelly. And my personal belief is it's not worth the effort to try to figure that out. And I'm a chemist, okay, and I did some research on this. It's like, you know what, we're going back to the top-rated laundry detergents. But these are examples of precipitation reactions. Okay.